Hello friends, I Dr. Minal Harde from Department of Pharmaceutical Chemistry, Modern College of Pharmacy, Nigri. Welcome you all. In the last lecture, we have covered the part 1 of thermogravimetric analysis. Now here the part 2 of thermogravimetric analysis. In this we are going to cover the factor affecting the TG curve and application of the thermogravimetry. In the last part we had covered definition, introduction, wide variety of application, principle and in brief about the instrumentation. So let's start with the factor affecting thermogravimetric analysis. So here two types of factor which affect the thermogravimetric curve. First is the instrumental factor, second is the characteristics of sample. In instrumental factor, three factors affect majorly, that is the heating rate, effect of furnace atmosphere and sample holder. In characteristics of sample, four factors affect such as weight of sample, sample particle size, compactness of sample and heat of reaction. So we will start with heating rate of instrumental factor. If a substance is being heated at fast heating rate, the temperature of decomposition will be higher than that of obtained at a slower rate of heating. So fast heating rate cause decomposition of sample than the slower heating rate. Then this is the one factor that affects the decomposition. Then second is effect of furnace atmosphere. The decomposition of calcium carbonate will take place at much higher temperature if carbon dioxide rather than nitrogen is used as a surrounding atmosphere. So this surrounding atmosphere is also very important. It decide the decomposition rate. It should be slower or faster. Then next is the sample holder. Generally, a shallow dish is preferred over a high form cone-shaped crucible because in the former there is a rapid gaseous exchange between the sample and the surrounding atmosphere. So the role of sample holder is also very major in the decomposition rate of the sample. So all this about the instrumental factor. Now we will see about the characteristics of sample. In that, weight of sample. If a large amount of sample is used, there occur a deviation from linearity as the temperature rises. Hence, a small sample is preferred over the larger one. Then next is the sample particle size. Sample particle size is also plays an important role in the decomposition. If the particle size is greater, its decomposition will take place at higher temperature than the smaller particle. Then next is compactness of sample which affect decomposition. If the compact sample will decompose at higher temperature than the loose sample. So compact sample will decompose at higher temperature. So loose sample is mostly preferred. Then heat of reaction. If a heat is exothermic or endothermic, the sample temperature will lead or lag behind the furnace temperature. So all this about the factors affecting the thermogravimetric analysis. Then next part is application of thermogravimetric analysis. So here thermogravimetric analysis is widely used in many areas. Majorly it shares a role in polymer industry, rubber industry or chemical industry. So for the melting studies, degree of crystallinity, glass transition studies, curring, cross-linking, oxidative stability study, kinetic study, composition analysis, softening of material, expansion or contraction of material. So and many more things we can study by using this thermogravimetric analysis in the polymer, rubber or chemical industry. In the pharmaceutical industry, we can study polymorphism, moisture content, purity, packaging, then amorphous phase studies or crystallinity phase studies, coating analysis, powder characteristics, high throughput screening. All this we can study in the pharmaceutical industry. In the life sciences, we can study protein melting or unfolding, protein denaturation, characteristics of live realized protein, or metabolic heat generation. So this way in the all this type of industry, this thermogravimetric play a very major role. So in detail we will see some applications of the thermogravimetric analysis. Suppose for the study of polymer, it provides information about decomposition mechanism in the polymer. Decomposition pattern is a characteristics of each kind of polymer, so useful for identification purpose in the polymer industry. Then for testing of sample purity it is also helpful. Example, an unusual weight loss below 100 degrees Celsius in the thermogravimetry of calcium oxalate is due to impurity of sample. So like this, impurity and purity of the sample we can measure by thermogravimetry. Then study of organic compounds. By making the use of DTA, thermogravimetry and use of derivatography, a large number of compounds can be studied. Example, in the study of decomposition of malonic acid, the phase transition occurred in the region of 70 degrees Celsius with the melting at about 140 degrees Celsius, followed by decomposition above 150 degrees Celsius. In case of decomposition of L-glutamic acid by Tg has 3 clear stages of decomposition in air. For quantitative analysis, the analysis of polyethylene formulated with fine carbon black particle inhibit degradation from exposure to sunlight is difficult by most other analytical method. The thermogravimetric method is most suitable for this polyethylene studies. In case of thermograph obtained by increasing temperature of pure calcium carbonate water at a rate of 5 degrees Celsius. Suppose we have to study the calcium carbonate, which is where the water is entrapped. So we are seeing the consequences over here. By keeping up to the 980 degrees Celsius, we are getting the calcium oxide. So how the elimination of water, carbon dioxide or carbon oxide can take place to get the calcium oxalate. In the last we can see by this diagram, calcium oxide we can get by this diagram. Then evaluation of suitable standard. So combined TG studies with infrared adsorption spectrophotometric study shows that substances such as magnesium, ammonium chloride, ammonium bicarbonate and ammonium fluoride cannot be used for preparing standard solution, while compounds like sodium dichromate, sodium carbonitrate, hydrogenium chloride, ascorbic acid and methyl glucamine are most suitable for preparing standard solution. And other applications are also very important. It is used for determination of correct drying temperature for precipitate used in gravimetric analysis. By using this, one can get accurate and reproducible result in thermogravimetric analysis. It is useful for identification of gases used while the sample temperature increases. The composition of residue is also determined in addition and also useful in identification of formulas of the residue. So herewith we are finishing the applications of the thermogravimetric analysis. Thank you.